So welcome to revision 17, and we're going just continuing through the sheets that you've got. So let's just look at these two. This is called using scale. Martha is buying carrots. The scale shows the amount she buys. What amount does she buy? Well, we can see here, we can see the 0, the 2 and the 4 and halfway. So we could just tap those in and we can see it's 3 kilograms. And then it says, Martha can use the scale to weigh 15 kilograms of apples. How would she go about doing 15 kilograms of apples? Well, I would say maybe we know that 5 3s are 15, so she could put it in 5 times at 3 kilograms. So she could do it that way, so she could do 5 times at 3 kilograms. Or, I mean, she could do a whole range of things. She could do, let's say, 3 lots of 4 kilograms and then plus 1 lot of 2 kilograms. 1 lot of 3, wouldn't it be? Yeah. So she could do that way. A whole range. Interesting sort of question. This question here, what speed is the car travelling at? Well, you have to look at the tiny little things, and you can see it's actually halfway through between 60 and 75, between 60 and 70. So it's 65, and it says there kilometers per hour. So you'd write kilometers per hour, and that's how you do those using the scale version ones. So then let's go down. Where are we next? We're at congruence and similarity. So congruence and similarity, what's all that about? Well, if something is congruent, it means it's identical. So if you think of identical twins, that they are exactly the same. So what you see there, you see one shape like this. Can you see anywhere like that? Well, yes, you can, because you see one that's reflected. So congruent shapes can be reflected, rotated. They just got to be exactly the same size and angle. So you can see those two shapes are identical. And then you've got another two shapes, one like this, and that also being rotated around, so it's like that. So those two shapes are also congruent because they're identical. So you'd match those pairings together and those pairings together. And it says there, which shape is congruent to shape E? This is shape E, so you'd say A. A is congruent. Then we get these two questions here, two triangles. And the question says, what's the question say? Triangles ABC and DEF are congruent, so it means they're identical, so the angles are the same, but not only the angles, because that would be similar, but you've actually got the sizes the same as well. And that's your C, and they say that is 8, that's 17, the longest side, the hypotenuse, and that's 15. And then it says write down the length of AC, or it says write down the length DF. Now DF again is the hypotenuse you've got here, and that length DF, if it's congruent, it's going to be 17. Write down the length AC. Well, they give you that's 8 already, that's weird. And write the length DE. Well, that one relates to that, so that is 8 as well. It's a strange thing. It's just teaching you, do you understand the word congruent? And that's the kind of key message to it. Then underneath that we have parallel lines as well as angles in polygons. So we're going to start off with two questions like this, and for this you need to remember 3 types of angles. You have the cangles, the fangles, and the zangles. Now we can't use those 3 anymore. You used to be able to use those ones, but the Z angles are connected with the letter A, and it's called alternate. So again, this is things you need to remember. The F angles are connected to C, Father Christmas, who you correspond with. So it's called corresponding. And then the cangles are also C, it's co-interior, ones that are inside the parallel lines. So, and that's what we're going to be using, those ones, no doubt, here. Those indicate that it's parallel. And so let's look at the first one. Work out the size of the angle X, and it will say give reasons for it as well. So we know that this is the letter F. Hopefully you can see the letter F here. So you've got like that, and that's your letter F. You might have to rotate it around and flip it, but you can see the F there. So it's this one here, and they are the same. So X equals 72 because it's corresponding. And so that's what you'd say, it's 72. This one here, it's kind of small to see, but that's 154 degrees. That's Y. And interestingly enough, they put two lines like that. And those lines are interesting. They also give you the letters for you to help. So they put that's A, C, B, and D. And it says, give the angle of Y and give reasons for. So this is interesting because this triangle in here is a special triangle. These two sides are the same, so therefore it's an isosceles triangle. So this is going to be an isosceles, meaning that this angle here and this angle here are going to be the same. And that might come in handy later on. So how am I going to do this? Well, there are lots and lots of ways to do this, but I'm going to do it here. I'm going to see this angle here is alternate with this one here. So that angle there is alternate to this 154, so it's 154 degrees. So that angle in there is 154. It's kind of a long process this, so bear with. I've now got a triangle, and those two sides are the same. That angle's 54. So these two, all the angles add up to 180, remember that. And you need to be writing all this out. So you go 180 minus 154 is equal to 26, and that's both angles. So if I divide that by 2, I know that that angle there is 13 degrees. So that little angle there is 13 degrees. Angles on a straight line, if you remember, angles on a straight line, what do they add up to? You're shouting at the screen, 180, well done. So that's going to be 180 minus the 13, which is 167 degrees. Quite a lot of process going on there. The next video, I'll go on to the next part of this session and show you what to do.